Today, we're going to talk about about quasi-experiments, which are similar to experiments. They often look like experiments, but there isn't a level of control that allows us to draw some of the conclusions that we do with a true experiment. We don't have the internal validity, for example. So we're going to talk about 4 different kinds. First of these is non-equivalent control groups, post-test only. We have 2 groups that are assessed at one point in time, and that time is after the intervention. So, for example, this research by Johnson and Goldstein was looking at organ donation, and they compared 2 groups. Groups where you had to opt in, you had to say, yes, I want to donate my organs, and countries where you have to opt out, where you have to say, I don't want to donate my organs. And you'll notice that there are much higher organ donation rates in these countries than in the opt-in countries. Now, these are called non-equivalent because we don't know whether the groups are similar or not. They're post-test only because we only see them after the intervention. So think about what kinds of recommendations you'd draw on this. Number of people have concluded that really the default should be opt-in or opt-out, I'm sorry, and that you then have to withdraw your willingness to donate, and that this would mean that there were more people donating organs in the US. Second type of quasi-experiment is a non-equivalent control group. So same as before, but here we have a pre-test and a post-test. So we have at least 2 groups. They're assessed at least twice, both before the intervention and after the intervention. So in this case, Margraf et al. Compared the self-esteem of people who underwent cosmetic surgery and people who considered it and then chose to not do that. And they compared those 2 groups at 4 different times, one of which was, their baseline before the surgery, and then at 3 later dates. And they have 3 different dependent variables: self-esteem, life satisfaction, and general attractiveness. So non-equivalent groups, we don't really know that these 2 groups are the same. And in fact, we probably suspect that there's something different about them, some reason why some people chose not to go ahead with the cosmetic surgery. Maybe they're more fearful about surgery. Maybe they're more aware of the potential concerns. So we don't know. There are a number of advantages here, just as we talked about with our 2-group test, as opposed to our 1-group test. We're able to make comparisons that give us a little bit better internal validity. So what kinds of recommendations would you make on this? You can think about that, right? What would you choose to do in this situation? And, really, as we're talking about any kind of research, you should be asking why, what kinds of recommendations would come from this? Interrupted time series. We have 1 group which is assessed before and after the intervention, and often in over a period of time. So the example used in your book is assessing the effects of the show 13 Reasons Why, which some people talked about as sensationalizing self-injury and suicidality. And they were looking at suicide rates during that period. So obviously the show was extremely popular, really talked about. And you have two different lines here. The blue line is predicted suicides for that month. So suicide rates are not the same throughout the year. And that's what you're seeing here. The orange line is what actually happened. And you'll see that at least for a period of several months, there were, more suicides. We'll come back to this as we're talking about internal validity and thinking about what can we conclude here. So again, what recommendations would you make? Now I'm going to show you quickly a number of different studies that take this that take this same kind of design and interrupted series. This is looking at cardiovascular disease events following the 2020 election, which for many people was a very stressful period of time. And you see both the number of events, but also the moving mean. So really, for our purposes, we might want to focus on the blue line. They have a control window and a risk window, and compared those two periods, and you'll see that there are considerably more cardiovascular events, heart attack and stroke during this period, right after the election. And it also takes, more than a month to drop back to baseline. Now, there have been other kinds of studies like this. So this one was after the 2016 election. And again, the red line is our 7-day moving average. And you can see that after that election, there were significantly more heart attacks and strokes for, at least a month. And after 9/11, we also saw that same pattern of increased time or increased cardiovascular events after 9/11. Now, think about if you were reading this as head of surgery, if you were reading it as a cardiologist, if you were reading it as someone with, cardiovascular problems, what kinds of recommendations would you draw? I might want more staffing, at least, right? And maybe to get maybe some sort of public service announcement beforehand. Now, we'll come back to this in the next chapter, but the fact that we have these 3 different patterns at 3 different times, but all similar, replicates it and increases our confidence about what we're finding here. Here's another interrupted series. In this case, in 2005, the federal assault weapons ban was dropped. And you see a considerable increase in the frequency of mass killings. Now, as we talked about earlier, in I think maybe chapter 2, we want to be paying attention to how something is defined, particularly mass shootings. Here, it's defined as a public place in which 4 or more victims were killed. They're excluding shootings with more conventionally motivated crimes, such as armed robbery or gang violence. So think about, why do these things matter? How might they impact your conclusions? And what could you do to strengthen your confidence in these data? Here's another interrupted series. In this case, there's a gun buyback in Australia, and notice the changes in suicide and suicide by firearm, which is that dotted line, and overall suicide rate. Finally, we have non-equivalent control group interrupted series. So at least 2 groups assessed before and after the intervention. So we have, in this case, we're comparing Florida and North Carolina and opioid overdoses or rates of overdose across time. And in both of these studies, or both of these states, we see that, well, in North Carolina, it appears to stabilize after the new law was introduced, legislating how opioids were available. And in Florida, the number of deaths seemed to drop, and drop fairly considerably. Again, think about what recommendations you draw. Should we keep this law, or should we sunset it? Some of you in your sociology classes have talked about blue-eyed, brown-eyed experiment, and Jane Elliott randomly assigned her blue-eyed children to one group, maybe initially the prejudiced group, and the brown-eyed children to the non-prejudiced, non-biased group, and then treated them, restricted their benefits, gave less praise, was much harsher with them as opposed to the other group. And then she reversed that. And we'll talk about that reversal later when we're talking about small n experiments. I'm going to stop here today and move on to our next video. Take care.